providing high-quality services. So, returning to it, it has been established more or less 30 years ago. It's an institute for supporting research infrastructure. This is its main area of activity. During the years, it has expanded its scope of activities in various areas. We have worked very close with the library community, mainly in Greece. We provide them a lot of services since our establishment also. And we also are very active in the latest years in the movement of open access. The NHRF was the first organization in Greece to sign the Berlin Declaration of Open Access and begin to promote this idea in Greece. So we're into building digital libraries, repositories, CRIS systems, of course, and we also provide digitization services to various Greek organizations. So we have a whole range of integrated activities in those areas. So, we have intensified our activities related to open access systems in the last few years. We have created a portal for the promotion of open access in Greece called openaccess.gr. Of course, this is interesting for somebody outside Greece. You can see also it's a bilingual site. You can see news about open access. You can see a mashup that we have made with repositories and electronic journals all over the world. So it's pretty interesting to visit. And we have quite a lot of activity in the area of repositories. Since the 1980s, we maintain the National Archive of Doctoral Dissertations by Greek academic institutions. So now we have more than actually 15,000 pieces online and more than 4 million pages in total. And we're now migrating this system to more contemporary depository infrastructure. We have built the institutional repository of the NHRF called Houssos, which is the symbol of the emblem of NHRF. And we maintain a thematic repository of humanities content called Foundations. Also, we're very active in the electronic publishing area. We have operating 5 e-journals in the humanities area. It's a very interesting task actually, because there you can see that there is opportunities for the dissemination of content for which there are not available the proper channels of distribution. I mean, for the natural sciences and engineering, people, researchers have already the ability to make their work known to the international community through the usual ways of publishing international journals and so on. In the humanities, they're a little bit behind in the technological exploitation of technological possibilities, and also the international cooperation in certain areas. So it's pretty important for them to have some publications that were available only in print until now to be made accessible throughout the internet to the worldwide community. So it really has an important value. So, and other things that we do, we have very heavily involved with services for libraries. We maintain our own library automation software, which has over 2,000 installations in Greek libraries, by far the repository in Greece. And we have also our own system for supporting the Union catalog of serials of Greek academic libraries. So it's also a homemade system. And there's also services for the academic research community and the business community, and the interaction of this community for the exploitation, for example, of research results. There will be a presentation today about a network called Enterprise Europe Network, which is a sequel of activities that have been around at the European level for more than 15 years now. EKT has a coordinator role in Greece for these activities and are really important for the dissemination and exploitation of research results. So, what I'm going to do is have an overview of CRIS systems that we have developed, and then at the end talk on some issues and also some experiences that we have in, let's say, getting the users to actively use our systems, both repositories, e-journals, and CRIS systems. I think it's of general interest, our experiences in this area, because it's the let's say, it's actually the ultimate goal, to make the users use the system. So I will talk a little bit about this. So EKT has been building CRIS systems since 1996, had some contacts with Europe's people that are now Europe's since that time. We have been a little behind for some years, but we're now back and very active again. So, examples of systems that we have built. For example, is the Greek Research Group database, which actually is a project that we did in collaboration with other bodies in Greece, other organizations in Greece. It's a very ambitious project aiming to build a national systems, not of based on a federation of CRIS systems of individual organizations, but straight in directly into a central database. This has been achieved. There are now in this database 8,500 researchers, 1,400 organizations, and more than 4,000 publications. It is built on the CRIS database schema. We have now the usual problem of update of this database, because this is data coming from many organizations. It's very difficult to coordinate and persuade the users to update the data. So we're planning to have to develop significant value-added services on top of this and facilitate this process, as well as improve a lot the quality of the data in this database. So this is an important system that will be the basis of some of our future activities related to CRIS. Also, an important activity relates to a database of research projects with Greek participation. Actually, this is the area where EKT started to work with CRIS. Now we have a system from data collected from bodies. So we have asked bodies to get structured data about projects with the participation of Greek organizations. And also we have collected data from national bodies. We merge this data, map this data to a CRIS database schema. As you understand, it was not an easy process. First of all, to obtain the data and also to do the mappings. But this is an operation, and now we have the problem of somehow automating this process. Codis is heading towards CRIS, so I think it will be much easier in the future, and we're also facing and trying to cope with this problem at the national level. We have also a couple of other systems, like a system developed during a project called Listeners, which was aiming to promote the research activity to facilitate the participation of organizations from Eastern countries to the European Union funded research. So this has been quite successful, and we have built a database of researchers and research organizations and projects in Russia, Ukraine, Belarus, and Moldova. So it's really important, based on CRIS. And also a funny part of our work that I consider funny is that the Ministry of Development in Greece has funded us to do a database of Greek women in research. I don't know why women are treated as a special category of researchers, but anyway, we have been that system.
If you use serif, you could just extract them. If you use a serif model, you could just extract them as a subset.
Exactly. So, let's, besides presenting some, let's say, facts, I'd like to present some issues and discuss them. Of course, our experiences with CRIS is that the model is complete. I mean, we could map almost every other database without significant loss of information. It's also very extensible, so it's very easy to use. CRIS XML has been very useful for compatibility with CRIS, mainly for smaller systems that, for which it is not very feasible in terms of cost to build to support CRIS at a very detailed level to build a proper system. An important thing for me is the potential availability of an open source platform for systems like CRIS, for serif-based CRIS. I mean, it's, I think it would be easier for organizations to adopt serif-based systems if there have been an open source platform that one could take and immediately install and immediately have a CRIS system. You see what happens with repositories. I mean, nowadays, everybody claims to have a repository because what they do is, okay, install a system. Maybe the system for 2 or 3 years has no data in it, no significant data in it, but they still call it a repository because they have taken a ready software and just installed it and made it available on the internet. But this shows the impact that the availability of a robust open source platform can have on the adoption of standards. So, of course, I'm talking about something that is robust. Open source sometimes is wrongly, sometimes is connected with systems that are not stable or not production ready and so on. But if there have been platforms like ePrints, DSpace, and so on in the repositories, and it's very good that some of these systems move to CRIS, and it's great that they are there. I think this would be very important. So, I will continue this presentation of issues in connection with our plans for the future. What we are planning to do now is create an integrated environment based on CRIS and repository data for NHRF. it's really important, we think, to have an integrated integration, high-level integration among these systems. And the point that we are right now is that we have built an institutional repository for NHRF, and we're trying to persuade people to use it and also introduce the CRIS in the picture as part of this activity. So our big goal for the next year or so is to make this, let's say, integrated system a living organism that will be used in the everyday activities of the researchers. So I think it's a problem that everybody faces, and it's very difficult to solve. Present a couple of our experiences. The first thing is our first experience was that researchers were really not very interested in any of this. They liked some of the ideas, but were not willing to put some effort on it. So what we did, for example, with the repositories was to retrospectively populate the repository with publications since the establishment of NHRF. Whereas Research Center, it's very difficult to say that from now on we will have a repository of publications or a CRIS with publications, because there are complex IPR issues to resolve. For example, universities, okay, say we have a repository, they put their diploma thesis, and quickly they have a critical mass of data. This is not the case for research centers, so we had to ingest into a repository a significant amount of data. Now we have around 4,000 publications, dating some of them in the 1950s, so it's they are quite old, and some of them are quite valuable, especially in the humanities area. The other thing was to, let's say, develop specialized solutions for the particular needs of researchers in different research areas. For example, in the natural sciences domain, they're really interested about research assessment. So researchers there, they already have their research disseminated. They publish in well-known international journals, so they're not really excited with their publications being online. They consider that already achieved. So it's very important to them to be able to produce, for example, reports about the activity of their research institutes, of course with great quality, which is where I think Serif goes in the picture, and it's very important to have robust research assessment reports that can be used, for example, for research monitoring and assessment. So this has been a very important driver for the researchers of NHRF to adopt these new systems for them. And the fact that until the end of the year there is a new round of evaluation of research centers in Greece has helped us a lot. It is very important to have the state money taking and be active in those activities, in those tasks. And so this is the one part. The humanities researchers are really sometimes more difficult to handle, as you can understand, but they have really valuable content, and some of them are really open to new ideas. So one could, they can be, let's say, approached in helping them to disseminate their results. It's very useful for us to have a parallel activity of e-publishing, to have turned very important print journals that have been published by NHRF, some of them for many decades, in electronic form, and this has made them much more positive towards us, also for other activities. And okay, they don't really care about the research assessment stuff, but however, it's important for them to present the information on the web and with a specific focus on thematic categorization. So for them, it's very important to have accurate and domain-specific, let's say, annotation about subject areas and thematic areas. So this is a point that is lacking in let's say, current system. And it's very important, for example, for browsing services for humanities, etc. So this is an area that we have explored and we have seen great interest by them. So we're running a little bit out of time, so I will just wrap up my presentation. Our current plans are also the adoption and development of a common CRIS platform used by Greek organizations. We're a little bit behind as seen as a whole country in the adoption of CRIS systems by academic and research organizations. So we're trying to promote those activities, and we have had some success until now. So an important first step is the development of a common CRIS platform. We will intensify our activities in research evaluation, which is very important and has a lot of results that are of interest in the research community, and also to further integrate advanced tools that we have developed and used in repositories, journals, and CRIS. Likewise, it's always about data, so we have in the course of our activities, we have developed some very important tools related to data cleaning, for example, double detection, automatic generation of authority files for example, for names of people, for names of organizations. One should note here that having, for example, a unique identifier might not be sufficient in some cases, because, okay, you have a unique identifier for a person in your database, but when your data originally comes from untrusted sources, where there's no identifier, then you have to do it in a manual way. So we have developed some semi-automatic mechanisms to help our quality control people to manage large sets of data. So it has been really important for us, for the success of our systems, and a very big requirement from the researchers of our institution and the users of our systems. And also, we have other activities related to schema matching, visualization, and so on. This is more or less technical stuff. So, that's about it. Thanks very much. Move on. If you have any questions, I'm available for discussing with everybody during the days of the meeting. Now, the next speaker is Professor Mara Nikolaidou of the Karakopolis University of Athens. It's a presentation related to a distributed architecture for building federated digital libraries. It's very much related to distributed systems that handle heterogeneous metadata. It's work of George Beridakis of the Department of Informatics and Telecommunications at the University of Athens. And I give the floor to Mara.
I would like to thank all of you for inviting us to this meeting, and of course the National Research Center and Houssos. We have a lovely weather in Greece these last days, and I hope that we will finish the presentation really quickly and you enjoy your tour in Acropolis, which will be very, very nice. But before you do that, you have to hear me, and actually, I'm going to talk a bit about the activities of the Library Computer Center of the University of Athens here in Greece, and I will talk to you about what we are planning to do now. I was the director of the Library Computer Center, although I'm not in the University of Athens anymore, but I've been, now I work for Karakopolis University. I have another position, but in any case, this is the work performed there. And actually, what I'm going to do is talk about our future plans on how to handle distributed digital collections in the University of Athens. And before I do that, I would like to talk to you about the University of Athens. It is actually the oldest university. It is the second largest in Greece, and it is spread all over the city of Athens. So it is distributed by nature. And it's very difficult actually to convince people, especially if you have cultural collections and archives perhaps, to move it outside the building. So even if it is digital collections, they would like to see the disc or the computer. Actually, their collection is really installed, so they can feel it is theirs. But besides that, there are also technical reasons of building distributed digital libraries and federated digital libraries. And what I'm going to do is talk about how we are planning to handle that, and talk a bit about what we have done so far as the Library Computer Center at the University of Athens. So a few words about the current state in federated digital libraries. Usually, from the technical perspective, we have a central server harvesting metadata from federated repositories, and in most cases, the Open Archive Initiative protocol for metadata harvesting is used. In such a case, digital library services are usually dependent on the repository software. And furthermore, it is difficult to build advanced services in the federated environment. So functionality offered in such an environment regarding the services provided is not very rich. We usually have a simple search mechanism which is offered to the users, and the overall architecture looks like that. We can have heterogeneous repositories. We usually talk using BOI PMH, and we collect all the necessary data to a central coded repository, and we build the services we want using this repository. So we have a lot of services which are not effectively supported. For example, we have to have a more complicated workflow for submitting, editing, and publishing digital objects. Managing digital collection is not easy to do because you have to do it in each repository separately. It would be nice if we could have a unified fashion to manage all digital libraries, or even actually find an automated way to create a new digital library. Because in most cases, when you have to create a new collection, you actually have to code some data. So I don't know if many of you are programmers, but what you have to do is to program a new program for each new collection. And what we would like to do is avoid that and provide some templates or any kind of resources to help the designer to automatically to build a digital collection in an automated fashion. Of course, you also need to have more complex services regarding digital content handling, conversion, watermarking, and so on, and you can apply in general fashion preservation policies. So if you look at distributed architecture and middleware, the concept of middleware is introduced to abstract digital objects for abstraction purposes. So this abstraction separates the physical or stored form of objects from the logical representation. If you were object-oriented programmers, I would say this is what we call typecasting. You're not familiar with it, I can see it in your eyes. We have decided to adopt a similar approach to create a middleware that interprets the structure and semantic of digital objects stored in different repository softwares located in multiple servers. The main difference is the following. Using harvesting, digital objects are imported to a central server in a simplified form. They don't have all the semantics they originally had, and the DL services are built on top of that. So we lose content, we lose information. A DL middleware presents the role of an interpreter between DL services and digital objects which remain located in their repositories. So the main goal here is to preserve all the information and actually enrich it as far as we can. This is what the proposed architecture would look like. So, if you see it from another perspective, what you want to do is make this middleware responsible for doing things you don't want your services to know about. So you simplify things for the programmers that are willing to produce services. And we all know that in our world, services provide additional value to the data we have originally stored in any repository. So this is the perspective we try to establish. And we call this middleware digital object abstraction layer, DOAL. And the scope is basically to build federated digital libraries and create reusable digital library services. DOAL provides an API for DL services, and services actually use an abstract and semantically rich form of digital objects independent from the repository they are stored in. So we separate the abstract form of the digital object and the stored form of the digital object. DOAL should work over heterogeneous repository software. The current version works using Fedora and vSpace. And also the digital object notion within DOAL should be handled independently from its stored form or forms. Because in this case, we might have a digital object, for example, a digital book, which is stored in more than one location. And the user doesn't have to know about it. To do that, we need to abstract digital objects. And DOAL uses an abstract form of digital objects that retain their semantics, that is metadata sets, digital content, relations, and behavior. And hides their repository-dependent characteristics, including location, software, and encoding used for the serialization. Abstraction of digital objects is realized using the digital object prototype mechanism, and I will talk about it a bit in a later slide. So the benefits. DOAL abstracts the serialized digital objects in a form manageable by DL services independently of the repository software where it is stored. It also associates digital objects to their prototype, so they are handled in a common manner by the DL services according to their type. What it means is that for each digital object I have in a library, for each digital artifact, I have to find a way to search it, to view it, to show it to the user. If I need to do it in an automatic fashion, I need to know how to do that. And if I want to have a portable solution, I have to store in the digital object all the behavior of it, that is, the methods used for its reproduction or viewing it and so on. In order to do that more effectively, I can remove this information from the stored digital object and add it in the digital object prototype. And the benefit of doing that is the harmonization of digital connections of different repositories that are parts of federated DL. Of course, using this architecture, one could also have distributed digital objects, which are used in a unified fashion, although parts of them are stored in multiple heterogeneous repositories. The concept of the digital object prototype has been implemented in Pergamon's Digital Library by the library's Computer Center at the University of Athens. And to do so, we had funding from many different European and national projects over the last 5 years. The DA is able to host heterogeneous digital collections using different metadata, digital contexts, hierarchies, and views in an automated fashion, but without any additional coding. And a common web interface for all collections is used by catalogers as well by end user. For each digital object, the type is assigned using the notion of the digital object prototype. Pergamos is a centralized three-tier architecture, so currently it works in one node. The Fedora Digital Repository version 2 is used as a core for storing and retrieving digital objects. The application logic layer uses the abstract digital objects, which are semantically rich, and helps the designer of the digital collection to easily add new collections in the system. This is a simplified architecture of the Pergamos digital library. We have Fedora, and on top of it we have the first version of Dome, the first implementation. As you can see, we have instances of stored objects and also prototypes, including the behaviors. And we have built digital library services on top of it. And we actually have now a cataloging module, a collection managing module, and a browsing module. And if you would like to see more of it, you can visit Pergamos at this address, pergamos.lib.ua.gr. Currently, there are 4 collections available to the public, but we have 8 more that are ready to be public as well. And we almost have 500,000 digital artifacts in these collections. Most of the collections have to do with cultural heritage. And the largest is the historical archive of the university. We also have different kinds of artifacts in this collection. We have a lot of papers, but we also have a lot of photographs or videos. And the whole project lasted for the duration of 4 years. But of course, the most difficult part here was to digitize the content and not to build the software. You can see some screenshots of Pergamos, and I have to say it is in Greek. You can, some parts can be translated in English, but not all of the collections. Here we can see a view of Sakharov's collection of musical manuscripts. And what I would like to say is that each time you add a new collection, you can do it by actually adding an XML file describing the digital object prototype which is related to this collection. So you don't have to build the interface all over again. And this is the benefit of digital object prototypes. You can see here a Byzantine music manuscript. So, since we were able to establish the use of prototypes, the next step is how to make Pergamos operate in a distributed fashion. And in order to do that, we need to have distributed digital objects So, in a way, we should allow for a digital object to be stored in different nodes. So, in this case, we have an example. I have a distributed digital objects, and a part of it, for example, the description using Dublin Core and the thumbnail image, which should be shown in a catalog, is stored in one node, while the high quality image and the image that is shown over the web is stored in another node. And this is the functionality we would like to achieve. And in order to do that, we need to have a more complicated architecture, so that those could actually operate distributed, which means it should be installed in every node participating in the federated digital library. And when you do that, you should be able to support different repository software, not only those here, but many others as well. So you need to have connectors, and the connectors is the part of the software which is responsible for actually establishing a connection with different repositories. You also need to have some registries, and you need to register all the repositories, and also you need to register the digital object prototypes you use, which should be common for all the nodes participating in the Federal Digital Library, and also you need a registry to handle distributed digital objects. You also need handles for them, because you have to create a pool of distributed digital objects, and of course you need to apply abstraction mechanisms. That is the way the digital object prototype mechanisms is applied. So what we are currently doing is that we are trying to implement this architecture. You can see the basic modules of the architecture in the slides. Registries give information about digital objects, repositories, and prototypes. Connectors are used to implement for each repository software the connection between the repository and the DOAL, and abstraction mechanisms is possible for the abstraction of digital objects according to their types. Finally, distributed digital object pool holds all the instances which are available to be used by digital library services. So how this has to do with how we would like it to work. We are not able to say it is working yet, but as an example, we can talk a bit about it. We have two different nodes, and the browser module is invoked in one of them. And we would like to view a specific digital object, which is DDO1. And as you can see here, within this specific node, the metadata is stored, but what the browser wants to do is actually to show the metadata and also the web image of the object. So it can obtain the metadata, but in order to obtain the web part, has to communicate with the DOAL, which is installed in the node where this web part actually lays. So the communication is performed between the DOAL part of the nodes, and the repositories are unaware of this communication. As you can see, we have an instance of the distributed digital object, which is the same instance for both nodes. And this kind of synchronization, because the object should be the same. This kind of synchronization is what we are trying to implement. And a few words about what we are currently doing. We have implemented the connectors for Fedora in this phase, and we are currently implementing the registry mechanisms. especially the distributed digital objects and prototypes registry. We are also implementing distributed digital object hardwares, and as a first version of the project is expected to be operational in February next February. And so this concludes my presentations. And if you have any questions, I'll be happy to answer.
Any questions for Professor Nicolai?
We're using harvesting to get data from libraries. No, it is a central server that you mentioned. It's not.
The main difference of this architecture is that we don't. But of course we don't use OI.
The middleware that you are using and translating. So what kind of protocol that you use?
It's custom made.
Okay. And how often are you updating the data inside the server?
You don't need to.
You don't need
Because you don't harvest any data. You leave the data where they are, but instead you put a module, an additional software where the register is. And this is what Dole does.
So even when I do a query, so it goes there and search through the.
Yeah. It's a different view of things.
Okay.
But to be honest, we haven't implemented the distributed version. Because in order to do that, you need to implement these digital object prototype mechanisms. And what we have established so far is that we have implemented prototyping mechanisms in a single node.
So
all these collections actually
are residing
in a central server. And what we are trying to do is make it work distributed. And there is also another catch, to be honest. And I haven't talked about ingesting. I mean, as I described the whole architecture, you have to have the architecture from scratch. So what we are also very interested in finding out is how you can actually import an already existing digital repository in the overall architecture. And you can do that. It's a technical issue that you can resolve, but we haven't actually done it yet.
I have another question. If I understand correctly, a big benefit from your approach is that you are able to create for almost any metadata schema all the application logic for the software to support it. For example, forms to enter data and so on. And this combined with the capability of distribution, where you have in different places a digital object and the metadata, creates a nice, let's say, separation of concerns, which I think it's something that is interesting as an architecture tool. You observe where maybe the digital repository is the place for the digital object and the metadata is located somewhere else, which is a CRIS system. I wanted to ask, are there any restrictions on the data that, on the metadata that you can support in your system? For example, you can generate automatically a big part of the application logic of the software to support some data schema. Are there any restrictions? For example, could you apply this approach for example, scientific data sets, which is a totally different, let's say, it's totally different data than digital objects?
Well, in our approach, you can do in our approach, we have a logical level and a physical level. At the logical level, you can describe your metadata any way you want. So you can define actually your own metadata schema. But in practice, you have to be able to handle the physical part as well. Because if you are using, for example, this space, you cannot expect that you can actually store any kind of metadata using this space. But if you use in a relational database, you can actually use any kind of metadata schema you like.
Okay, let's thank the speaker once more. This is normally now the time for coffee break, but I suggest that since we're a little bit ahead of schedule, and there is only one presentation remaining to do this, and then feel free to rest a little bit before we go to the appropriate, which requires some planning up the hill, so we need some energy for this.
Hello, my name is Pasquale. I am from the National Documentation Center. This is to win a little bit of time since I have the last presentation. And I would like to talk to you about the Enterprise Europe Network. It's the largest business network in the world, and I think we could be one of your main users, one of the main users of such research information systems. And I hope during this presentation you will understand why. So it is the largest business network in the world. It's called Enterprise Europe Network, but as you can see, there are contact points as well in countries that are not European, such as USA, China, Russia. There are contact points in 40 countries. We are more than 600 organizations involved with more than 5,000 persons involved. And what we are doing? Well, we originate from two very large European networks that are dedicated to small and medium enterprises. They are the Euroinfo Center networks that were given information on EU policies, and the Innovation Relations Center network that were doing technology transfer. And this is the consortium. The network here in Greece is composed of 16 partners. We are 2 research and technology organizations, 5 chambers of commerce, 3 industrial associations, 1 regional development company, 4 R&D companies, and 1 public organization for SME support. The National Documentation Center is the coordinator, and we were in the previous phase Innovation Relay Center, and we are NCP, National Contact Point. So what do we provide? We are one-stop shop for companies, as well for organizations, for research organizations, but for companies mainly. And what we provide, as I have told you, information on EU policies and initiatives. We provide innovation, technology, and knowledge transfer services, and we encourage a small and medium enterprise to participate in the framework program and to collaborate, obviously, with research organizations. This network and this organization that we are involved, these services we provide it free of charge, and there is the idea of the one-stop shop. Every time that a company will come to us, we provide all sorts of information. What we try to do is to enhance international collaboration at all levels, at commercial level, at research level, and at technological level mainly. We have a sectorial approach. I mean that during this network of people, we have created 18 sector groups. You can see there are topics that are related, that are in very close synergy with the themes of the Framework Program 7. We use a lot of tools, of implementation tools, because we are collating information from academia and companies, and we are promoting to a large number of end users. We are multipliers of information. And what are our tools? Is a web, there are databases. This is mainly what is most important for you. We have 3 types of databases. There are databases for international collaboration, one at commercial level, one at technological, another one at technological level, and finally the third one at research collaboration. And as you can see, we have different tools. This is the website of the network. This is one of the network's tools that may interest you. Since we are multiplier of information, this is an IT tool that our end users are using. In this case, they are submitting their contact details, and they are telling us, please, I want you to send me information on technological collaborations on this sector using these keywords, etc. And this is how it comes, the information to the end user, to the email. As you can see, there is here a technological collaboration for drugs, and the criteria, selected criteria was health, pharmaceutics, etc. And we are the intermediate of this information. This is myself, Cristina Pascual, here. The end user will receive this information and will contact me in order to see, I am interested in this international collaboration and I want you to provide me contact details on the organization that is behind this international collaboration. So, one of our main targets is the valorization of research results. And here is where you can help us very, very much. So, what is valorization can be defined as all initiatives and activities undertaken with a view to increasing the value of research results and more generally enhancing knowledge. This is the different steps. And here it is where is your experience. And for us it's very important to have access to research information systems that provide reliable and comprehensive information on research results. Because so far we detect the research results through on-site visits or through looking in research organization, website, etc. So here is where the enterprise network enters. It detects the research result, and in the first step it will assess if it is really innovative, if it is really something that is novel, that has advantages, and the readiness to the market. In the step 2, we will provide information in intellectual property rights and how to protect these research results. And in the step 3, what we will do is the exploitation and dissemination of this research result in order to reach the market. So this is the form, the record that we use for our database, and especially for our technological database. And as you can see, all our database have the same format, more or less. At the beginning, they are the organization details of the organization that wants to establish an international collaboration. Then, there is the information on the technology, if a research organization of a company is offering a technology or is requesting a technology. And then which type of partner is interested in it. It could be industry, it could be academia, it could be different type of partners, from which country, etc. So you can see the submission of a technology offer, as we call, and that it has a positive assessment. It is when a research result we think that is ready to reach the market. These are, for us, the fields that are really important. A show title of what you are offering, an abstract, a description, and especially these main advantages and innovative aspect. In the partner sought, if it is a research result that is ready to reach the market, it will be industry and venture capital in the kind of collaboration, licensing, commercial, venture capital agreements. Okay, this is a negative assessment. The research result is not ready to reach the market. And in reality, what you are requesting, the organization is requesting further research collaboration, or is requesting to have contact with industry in order to develop a prototype, a laboratory prototype, an industrial prototype. So the kind of collaboration is further research and technological development.